Hi, my name is RAUL MACHADO. I'm going to do the presentation for the Assignment 1 in Causal Inference in Registry Studies this fall. Okay. The first exercise was assume the data is generated by a uniform random experiment, make a histogram, and the sampling distribution of the difference in means test statistic. Well, as you can see, I use test statistic, which is defined as a function of the outcome and treatment assignment. The difference means test statistics implies using the values from the table 1, and you can see there. And for instance, the simple mean difference is there. Then the sampling distribution, which people ask, is what they asked there, of the different means can be thought of as a distribution that would result if we repeat the following 3 steps. First, the sampling of T1 and T1 separately with replacement, compute the means of the 2 samples, and then the division, then repeat it again. As you can see, the histogram shows is around very close to 0.6, which is also seen in this simple difference, okay? And this is the code. Here you use it directly from the table 1, and you can get that, or you can create a function, okay? And then the Monte Carlo, you can use the step 1 and 2, you can use replicate, use the sample mean, the subset. I use that for T1 for the treatment of the control group, and then the difference. And the histogram is plotted using this, okay? Now, how the p-value for the feature sharp null hypothesis of no treatment effect. In the problem, it is a feature sharp null hypothesis of no treatment effect, which means that the difference has to be 0, and thus the treatment and the control is used to impute the missing potential outcome under the given condition. The given condition was the assumption, all right? So at the beginning of the first line of then the p-value can be computed directly from the null distribution. The idea is based on the fact that although all the potential outcomes are constant under the sharp null hypothesis, the test statistic will still vary based on who received the treatment. All of the possible ways that the test statistic could vary under the sharp null hypothesis can be captured by permutation. Given that we have the population of 10 individuals and 5 assignment to treatment, then there are 252 different possible assignment vectors, and store them in a matrix omega. I call it omega, but for instance, in the literature, sometimes it's W, okay? The test statistic is calculated using the each potential assignment vector obtained in point 1, at this point at the top, together with a fixed vector of outcome. The p-value can be calculated. For instance, here I have one formula with a standard where the I is indicator and the omega, the parenthesis is the modulo, is counting the number of elements, okay? And the equivalent for all this, I calculated for the left, for the right, and the two-sided. So we have 3 values here for the p-values for the left, for the right, and for the two-sided, okay? And the code is here. You can see, for instance, the null hypothesis is you compute omega. Here you assign the 252, and then you compute, assign the zeros and they put the ones, and you compute the null distribution. Okay. Now, what is the next step is to calculate the point estimate of a 95 confidence interval according to Newman. The point estimate and the 95 confidence interval according to Newman is calculated here. The potential outcomes are considered fixed as in the Fisher approach, and the only random component is the vector treatment assignment Umea. Okay? The Newman point estimate, there's a formula. For instance, you can see the formula in one of the literature for Rubin books, for instance. This is one of them. And here are the NT are the unit randomly selected to be assigned treatment, and the remaining are assigned to control. So the Newman 95% confidence interval is the diff, which is the point estimate, plus minus 1.96 square root of the variance. So the variance is calculated in this form. However, let me point out one thing is that there are missing values in the table 1 where the question marks are seen. If you're seeing that first, let me go back. Sorry, let me go back and show the first table. You see the missing values here. Okay. So I have to do this using the assumption that you see the missing values are so the difference at 0. Okay, the sharp null. But anyway, so that instead of so it would be estimation would be based on the 0, okay, not 0.6 on the other in the case in the first exercise, the part A, and the result is very close to the confidence interval 95. You can see here 1.32 more or less, plus minus. Okay. Now, exercise 2. Consider the following data generating process. What is expectation of t? Expectation of t is estimation. It is the probability that the treatment is t is equal to the treatment based conditional to some covariates, which is using the causal inference literature to estimate the propensity score used to obtain the variables, the covariates. Okay, so that is the expectation of t is the probability that t equals 1 given a set of covariates. An example is subject E has a propensity score of 0.73, means that given the covariates values, there are 73% chance they will be treated. Okay. Now, calculate the population estimate. The average causal effect, also determined as the average treatment effect, is calculated in this way because the expectation of the Bernoulli is give the probability. Okay, the probability of success. So the difference are these numbers already given, and fill into the formula, and you get the values. Okay. Of course, because X will be many of them, you get many values, but I present only the unique values. Okay. Now when it comes to the conditional, this is important because t depends on X, but also the outcomes y1 and y0, which is the treatment and control, also depends on X. So they are confounder. S is a confounder. Okay, so the expectation of y0 minus y1 minus y0 given t1 is not the same as expectation of y minus y0 due to both t and the outcomes depends on the X is a confounder. Here the focus of the analysis will be on the subpopulation of the same individuals who has actually received treatment. Okay, and the second would be equivalent. Okay, but in this case would be t equals 0. Jag har ett problem här med den här delen, det vill säga ATT och ATC. Det tycks om det är en enkel grej kopplat till betingad sannolikhet, men det klickar inte nu. Jag vet att X är confounder. Finns någon ledtråd som du kan ge, snälla? Okay. C-delen. Assume that the data generating process above describe the following variables. The point here is to explain the confounder describing the data generating process in words. Okay, a confounder is a variable that influences both the independent variable and the dependent variable. The example of the confounding variable is presented in the figure below. For instance, where x is confounds the relation between t and y, since x is the cause of both x, t, and y. In some cases, there is no connection between the treatment and outcome. Okay, but the point here is that both confounds t and influence t and y. In the particular problem, the outcome of y equal 1 means sick leave from the work during the last year, which depends on the two independent variables x and y, that is, whether a person has a university degree and his or her mother has a university degree based on the given relations. In addition, t is an indicator of employment, which is also dependent on x1 and x2. That is, x1 is a confounder because it influences t and y. In other words, a person who has a university degree, x1 for instance, is more likely to be employed and less likely to the individual to has been sick for leave. Okay. In addition, that's why y equals 0. In addition, if the individual mother has a university degree, then the person is more likely to get a university degree himself. And then we go to the point that and then the person who has a university degree is more likely to be employed and less likely to that individual has been on sick leave from work for the last. Okay, so it's important education both for him and from the parents. Okay, so that confound both the employment and sick for leave. Okay, less people with education are more likely to be employed and less likely to get sick. Okej, slut. Det är slut. Det var 12 minuter. Okej. Tack så mycket.